Okay, we want to calculate the variance and standard deviation of a sample of gasoline prices from around the world. So since it's a sample, I'm going to use the formula for the sample variance, S squared. And it's taking all of the data values, each data value, subtracting the average from the sample, from each one of them, squaring each of those differences, adding them all up, and dividing by the sample size, subtract 1. To get the standard deviation, that would just be taking the square root of the variance, or the square root of the sum of the square differences, again over n minus 1. Now, anytime you see a summation sign in a formula and see a subscript I, and in this case on the x, you're going to set up a table and do a calculation on each data value and then add those calculations together. So I'm going to set up a table, and in the first column I'm going to list all of my data values. So that would be the sample of 10 gasoline prices, 5.91, 2.61, 5.93, 2.62, 5.57, 2.72, 1.74, these are all dollar amounts, 4.24, 5.8, and 5.54. Now, first calculation I'm going to make, thinking of the order of operations, working within the innermost grouping symbols first, I need to take each of these data values and subtract the average. And since this is from a sample, I use the symbol X bar for the average. To get the average, I'm just going to add up all of the values in the first column there and divide by 10 to get the average. The average turns out to be, in this problem, 4.268. So that's a measure of location. What's the average? The sample average gas price of these 10 prices is $4.26, or actually $4.27 rounding. Next, I'm going to take each data value and subtract this average. So $5.91, or 5.91, subtract 4.268, I get 1.642. Now notice I'm not trying to round off very much in these, because these calculations are all going to be added together, and if I have very much error in any one of them, that error has a tendency to accumulate, and my answer will be even further off. So I want to be careful and not do too much rounding when I'm going through this process. You can see that a standard deviation is a cumbersome calculation to make. And ultimately, we're going to want to be able to do this with software such as Excel. So where I'm down here is 1.74. I'm going to subtract 4.268 from that, and I'm going to get a negative 2.528. Notice that some of these values are positive and some are negative. Positive just simply means that the data value is larger than the mean, and negative would indicate that the data value is smaller than the mean. $4.24, subtract $4.26.8 would be a negative 0.028. 5.8 subtract 4.268 is 1.532. And then the last one there, 5.54 subtract 4.268, 1.272. So I've taken each data value and subtracted the average. The next thing with the order of operations is to go ahead and square these values. So I'm going to take each of these differences that I just calculated and then square them. And again, I'm going to try to avoid as much rounding as I can. 2.696164. I could probably get away with a little bit more rounding than that, but 2.748964. And the next one, 2.762244. 2.715904. 1.302 squared is 1.695204. Negative 1.548 squared is 2.396304. Negative 2.528 squared, 6.390784. Then we have 0.000784 and 2.347024, and then lastly 1.617984. Now notice in the formula, we're calculating the variance. Notice in the formula, first thing we do is to take the difference between the data values and the average, working in the innermost grouping symbols first. Then we square those differences, which we've just done. And then what would be the next thing we would do? We would add them all together. And that would give us the numerator for our formula. So that's sum of the square differences, adding all the values in this column together, which by the way are all positive, right, because we squared, 25.37136. And that becomes the numerator in our formula. So we'll put 25.37136 divided by 10 minus 1, or 9, and we get, put that into the calculator there, 25.37136 divided by 9 is 2.81904, which is our sample variance. We could just take the square root of that to get the standard deviation. The standard deviation is going to be probably the most common calculation that we'll make for variance. So I'm just going to go ahead and repeat the formula here. The sum of the square differences, which we've already calculated, divided by the sample size, subtract 1. So I'm basically taking the square root of the 25.37136 divided by 10 minus 1, which is equal to 25.37136 divided by 9, which is the square root of 2.81904, and that gives me 1.678997, on, or approximately $1.68 is the sample standard deviation. And that's a lot of work to get that value, that answer. And you can see why the technology is going to come in real handy. In Lab 1, you will learn how to use Excel to get these calculations along with others. And we will be using that more and more as we go on in the course.